Good morning, guys. I hope everybody had a nice sunny day yesterday. It was beautiful out. I definitely enjoyed some time outside. I hope you did too. Um, Wednesday and Thursday this week, I had you complete a gizmo over the course of 2 days. I wanted to make sure that you put the time and effort into the gizmo as needed, so I gave you 2 days to complete that. And today we are going to go over the gizmo. Now we're going to go over the gizmo, and I'm going to walk you through it like I would in class, but you are going to correct your gizmo at home, okay? So make sure that you are correcting it as you go along, or as I go along today, that you are correcting your gizmo. If you find I'm going too fast for you, because I don't have the the advantage of having you sitting in front of me, so I can watch to see how long, if I should speed up, slow down, etc. So if you find I'm going too fast for you, please pause the video, catch up, and then you can go back and press play, okay? You are correcting the gizmo today, which is Friday, because Monday you are going to have a gizmo concept check, okay? So we will have that gizmo concept check on Monday, and that will be a formative grade. Remember, formatives are only given from 9:30 to 11 and 12:45 to 2:15, so make sure you manage your time appropriately on Monday. Log on to Socrative. I am also going to have you log into your typical room. So if your typical room is Vastal 1, you're going to log into Vastal 1 on Monday. And this is because I think I found a way that I can just send you an email with your Socrative report so that you know how you did. Okay? So we're going to switch that up. I know that's new from what I've been doing since we started remote learning, but we are going to switch that up starting on Monday, okay? So, our prior knowledge questions. So it talks about a buoy being anchored to the ocean floor and a large wave approaches the buoy. How will the buoy move as the wave goes by? The buoy will move up and down as the wave passes, okay? So you'll see the buoy move up when the crest of the wave is underneath the buoy, and then back down to the trough, and then back up to the crest, okay? The two images show side views of ocean waves. How are they the same or different? Just different, I'm sorry. The wave on the left has a higher amplitude, but a shorter wavelength. Okay, so amplitude, remember, is from the normal to the crest, and wavelength is the same spot on two separate waves. So from crest to crest, okay? So that we can see that this amplitude is more, but the wavelength is shorter. So now we have our gizmo warm-up. In our gizmo warm-up, we're first looking at the motion of a transverse wave. So if you look at the gizmo over here, I have transverse all set up, and I press play, and we see the wave motion, or the disturbance, is going up and down, but the wave is traveling left to right. Okay, so you should see that. Okay, and then it asks the same question, but with a longitudinal wave. So you press play, and you should see that the wave motion, or the disturbance, is going left to right, and so is the wave. It is traveling left to right. Okay, so longitudinal is parallel to the disturbance, transverse is perpendicular. So going back up here, so we would need transverse, amplitude set to 20, frequency at 1, tension at 2, and density at 2. I just got to move my screen a little bit. Okay. So we have those all set up, and we press play, and you should see, like I said, the same thing. The wave motion, the hand moves up and down, and what is the green dot doing? Now, I know the green dot is kind of hard to see here, so I'm going to turn the lights off, okay? You can see that green dot, and that green dot is going up and down with the hand, okay? And then the crests appear to be moving left to right, okay? So they're moving in this direction, okay? Now, it asks you to measure with the lights on. So I'm going to press pause. So I turn my lights back on, and I'm also going to click Show Rulers, and it asks about the wavelength. So it says use the horizontal ruler to measure the horizontal distance between two crests. So I bring my ruler down, and I look at my two crests. Remember, it's the same point to the same point. So I start at 0 and end at 100, so it's about 100 centimeters. And then two troughs should be the same distance, okay, because that's the wavelength. Okay, so 0 to 100. So again, it's 100 centimeters. And now we are going to click on Show Grid. Okay, and I'm going to move my ruler back up here and get rid of my ruler. So the Show Grid, I'm looking for my amplitude. So this line across here is the normal, okay? So this is my normal, and then the middle of here would be my crest. So from here to here is the amplitude is 20 centimeters, okay? So from here up, and I go across to look, 20 centimeters. Now we're going to do the same thing now with longitudinal waves. So longitudinal, and then just making sure all my settings are right, which they're not. One, and the tension 2, and density 1. So density, I need to move to 1. Okay. So I press play. And again, we see this motion that the hand moves left to right in a push and pull motion. The green dot moves side to side like it did, so like the hand motion, okay? So this is parallel to the hand motion. And then follow the motion of a single compression. How does the compression move? And it looks like the compression is moving left to right, okay? So no matter what, in both examples, the waves are moving left to right. Okay? And now we're going to click pause. And we're going to show our rulers. Put my lights on, okay? It says the wavelength of the longitudinal is equal to the distance between two successive compressions or refractions. So we take a look. This is about the beginning of my refraction to the next one. So here's about the beginning, and here's the beginning of the next compression, okay? So this is my compression. This is the refraction, okay? So see how they're close together? That's the compression. So this begins being close together, and so does over here. So it's about 140 centimeters. And now it's asking me to click reset, and it's talking about the amplitude. So what we're going to do here is I'm going to take the lights off again. I'm going to press play, pause, and now it's saying what is the width of the green trace. So I bring my ruler down. That's about 20 centimeters. Now that would be from the whole wave. So from crest to trough, it would be the whole wave. So I have to take that in half. So the amplitude is actually 10 centimeters. Okay. And now we're moving on to activity B. I hope activity A was good for you guys, okay? Activity B was a little bit more tricky. There was some more math involved than some of the other ones, okay? So, so now we're looking at what factors affect wavelength, speed, and power of waves, okay? So how much energy is in that wave, okay? So I'm clicking reset, transverse, amplitude is at 20, frequency is at 0.75, tension is at 3, and density is at 1. Okay. And it says record the speed of the wave. Oh, I gotta move this. I'm gonna move my video up here so that we can see everything over here going on. Okay. And then I'm gonna press play. Okay, so here we have the wave. Okay, and this is where we're finding the wave speed. So 173.2 centimeters per second. And remember, don't forget your units, okay? So all you have to do is copy that down over here. And it says the wavelength and speed of a wave can be influenced by many factors. Adjust the amplitude, frequency, tension, and density as described. So I didn't have you do the tension and density. I just wanted you to do the amplitude and frequency. Okay. Then report whether this causes the wavelength and the wave speed to increase or decrease. Return each variable to the original value after the experiment. Okay, so if I press pause and I increase the amplitude to 40, okay? And press play. It should have no effect on the wavelength and no effect on the wave speed. As you see, my wave speed remained the same, okay? So now I'm going to press pause, and I'm going to move this back to 20, and I'm going to increase the frequency. So I'm just going to go up all the way. When I increase the frequency, what you should see is a decrease in wavelength, okay? And that's because I'm making more waves happen in a given amount of time, so they have to be smaller, okay? And then no effect on the wave speed. As you see, the speed has remained the same. Now, this one. So I'm clicking reset, turn off show rulers, because we don't need the rulers anymore. Set tension to 2. Density to 1. And then the power of a wave is the amount of energy it transmits every second. So this is directly related to energy, which we just completed our energy unit. So hopefully you remember all about energy, okay? The power of the wave, like I said, is displayed below when the spring is pressed, which means when I click play, okay? So record the wave power for each of the settings. So for my control set A, my amplitude is at 10. And my frequency is at 0.6. Okay, and I press play. And I have a wave power of about 0.1. Okay, now I'll press pause, and I'm going to now test it out at 20 centimeters. And I have a wave power of 0.4. Okay, and then I'm going to set it to 40 centimeters. And I have a wave power of 1.6. Okay, so as you should see that these are at least increasing. Later on, we'll get into the mathematical calculation, but right now, at a minimum, you should see that as I increase the amplitude, the power of the wave increases. Now I'm going to do control set B. Okay, so my amplitude is back at 20. Okay, and then I'm going to set the frequency to 0.5 and press play. And my wave power is at 0.279, and then set my frequency to 1 and press play. And my wave power is at 1.12. Okay? So what factors increase the power of the wave? You should have seen both increasing amplitude and frequency cause the power or the energy of the wave to increase as well. So this is what I was talking about with the mathematical calculation. So what is the effect on power when the amplitude goes from 10 to 20 centimeters? Just look for a mathematical relationship. So if I double the amplitude, so right here where I doubled the amplitude, the power of the wave is 4 times greater. And how you get that are by taking these two numbers, and dividing them. So 0.402 let's see if I can type in the document right now. 0.402 divided by 0.1 should give you approximately 4. So that will be 4 times greater. Okay? And now, when I look at B, it says, what is the effect on the power of the amplitude from 10 to 40? Okay? So I'm looking at 10, so it's 0.1 to 40, which is 1.61. So 1.61 divided by 0.1 should give me approximately 16. Okay, so it will be 16 times greater. Okay, same thing for experiment B. What is the effect of the power when frequency is doubled? So if I double the frequency, the power is 4 times greater. I did the same thing. 1.12 divided by 0.279, and you get approximately 4. Now these are approximate numbers. I know you're not exactly getting 4, but these are you're getting about 4. Okay. Now there is a relationship between energy and amplitude and energy and frequency. They are two different relationships. As you'll see as we continue talking about this today and Monday. But just keep in mind, there are two different relationships there, okay? But they both do affect energy, okay? So both amplitude and frequency. So now it says for longitudinal, what is the power of the longitudinal wave? You get 0.402, which was the same as we had up here with these settings. So does changing the type of wave have an effect on its power? No, it does not. So longitudinal versus transverse waves, it doesn't matter which type of wave you have, you'll have the same amount of power there. Okay? Hopefully you all logged into the assessment questions. If you did not do them yet, please do them now and just send me an email that you did them late. I already have checked to see if you did them, so I don't get a notification if you do them late. So please just send me an email that you completed them so I can give you credit for that, okay? So I hope this video was helpful. If not, please reach out to me and I will get back to you to help, okay? Have a good rest of your day, guys.